to do that is we want to talk a little bit about how this forest came to be in the first place and the characteristics of the site and the species composition. So before I start talking about that, I think, Amber, you had the students measure.
Yeah, so you all just turned in a lab report. So I'm curious to see what you found out. So let's start with species diversity. We'll go with species richness. And we have 5 different stands, right? So start with team 1. Team 1.
So
how many species of trees did you have?
We got 8.
8?
But then 4 of them were primarily dominant, and then 4 we only had 1 sample out of 40 of.
So you had 8. Team 2, how many species? 4. Okay. Team 3?
6.
6. Team 4? Wow, 11. Wow. Okay. Team 5?
We had 7.
Okay, so from 4 to 11, that's a pretty good range. Almost a 3-fold difference. In terms of importance value, your number 1 species in terms of importance value, Team 1, what did you have?
Balsam fir.
Balsam fir. Team 2? Red spruce. That was, which was where I kept saying this is our red spruce stand. Team 3?
Pretty sure it was Eastern hemlock.
Eastern hemlock. Okay. Team 4? So do you know what your number 1 for importance value was? Red maple. Okay. And team 5?
Red spruce.
Red spruce. Okay, so a variety, I think, at least 4 different species. So that says something about not only the diversity, but the variability across a fairly small area of this forest. It's not that you all were very spread out, right? You were kind of all in adjacent stands from one another. So that says something about the diversity of the type of forest we're in, which
this
you can expand on.
This is a primarily even-aged forest. There are some younger age classes throughout here, but this originated from what was old agricultural land. And this is believed to have been pastured, not plowed, and you can tell that because of the pit and mound topography that's on the site from the tree falls back in the day that have decayed. If this had been plowed, it would be more level today than it is. So the species composition and structure that we see today are in part due to that history. So there was open area that different trees seeded in and started growing all together. But then there are also underlying differences in site type. So I'm sure some of your areas that you were looking at were more wet than others, and that will have an influence on the species that will become most dominant. And then finally, since this forest originated, there has been different types of periodic cutting. So we look in here and we do see some signs of stumps in here. So there has been some management here in the past. So when we look at the species that we have, we're going to see just today along the road a lot of eastern white pine. That is a very common old field species in New England. It really likes the disturbed open conditions that originate from fields. But then we'll also see hardwoods. We heard shade-tolerant eastern hemlock, red maple. And what we often will see happen that changes structure and composition over time are different types of disturbances. So if the canopy has remained fairly closed, a shade-tolerant species like eastern hemlock might start growing underneath in the shaded microenvironment. On the other hand, if there have been natural openings from tree falls or past harvesting, you might see examples of trees that are more shade intolerant or shorter lived, and that's a sign that there has been a disturbance in that area in the past. So that's how we can sort of link what we see in the forest today in terms of the sizes and ages of trees and the species we have to what's happened in the past. So often when we're managing forests, it's important to think not only about what do I want this to be in the future, but how did it get to be the way it is now? Because if there's attributes of that that you want to continue, you'll want to base your silvicultural prescription on the types of things that naturally occurred to create similar openings or similar disturbances. So that's something that we're going to look at specifically today.
And regionally, we're in the Acadian forest, which is characteristically kind of a transition zone between more hardwood-dominated forest to to the south, so I think it's sort of like Appalachian hardwoods. Some of you might be from down farther that region. And the boreal forest to the north. So you get, I think that's part of why there's a lot of diversity here, is because you've got that mixture of hardwoods and softwoods coming together in this region. I don't know if you want to say more about that. But
So some of the species that you would encounter out here were at the northern part of their range. Northern red oak is an example of that. That isn't a very common species above us. However, others are at the southern part of their range, and balsam fir is a good example of that. That's not abundant south of that. So that's called an ecotone, a transition between the broadleaf and boreal forest. And because of that, we have this extra species diversity. And so we talk about mixed species stands generally, and that just means that you have a number of species present. But there's also a category within that that are called mixed woods, and that refers specifically to hardwoods and softwoods together. And there can be some advantages to growing those two together because they're so different in their silvical properties. So I know the species that you all will have found on your plots that we see some of here, the eastern white pine, mid-tolerant, the eastern hemlock and the red spruce, very shade tolerant. We have the red maple, which is a sprouting species, so can become more prolific with cast cutting. And then the shade intolerance, like the birches, particularly the paper birch or the aspen, will be more prone to come in a stand that is more open.
perfect.
So I think that was all I had here. So what we're going to do now, did anyone have questions about the old field forest or what's happened here? Okay. So we're now going to walk further down the road, and we're going to look at two different examples of management and talk about why they were done, what worked, and what didn't work. Any other question? Yes, you can have hemlocks growing underneath hardwoods as well. Eastern hemlock is the most shade tolerant of all the species that we have here in this region. So as long as there's a nearby seed source and a suitable seed bed, they can persist in a very shaded condition for like 100 years beneath the canopy of something else. Yep. Mm-hmm.
So when they were farming here, they didn't plow, they just like pasture on top of it.
It was just pasture land. So they just had like cows or things out here grazing. Yep, so that kept the vegetation back. They cleared it and it kept the vegetation back, but it didn't totally flatten it out.
Yeah.
Yep.
Yeah, because if you ran through here with plows, you would have gotten rid of all these mounds, right? So.
Okay.
Yeah, this is a tough place to grow crops. You know, imagine running a plow through all this rocky soil, and
Yep.
yeah, that's why so much farmland was abandoned, in especially northern New England, because the soils are just not great for crop agriculture.
Yep.
Yeah.
Do we have another question?
In other words, how long ago was this abandoned, maybe?
I mean, to tell that, we would need to look at the ages of the largest trees, and I'm guessing those pine are at least 80 years old, 80 to probably 120 years old would be my guess. So that would tell us about when they stopped using this for agricultural land and let it revert to forest.
So that, if we did the math, that would put us back in like the 1930s, 1940s, you know, like Depression era. That's when a lot of this land was abandoned. So a lot of land was abandoned and reverted to, in some places, public land or other ownerships. So yeah, that was a tough time to be in agriculture. So a lot of land was abandoned in the 30s.
So I haven't looked at old maps from the university, but I know in the special collections in the university library, they have maps that show the original university buildings and the surrounding area and what it all was, and it would be interesting to take a look at that. And if someone wanted to know more about a property, often looking at old tax maps or deeds can give you information about what happened.
Or local historical societies
Yes.
that have those kind of cool archives.
Or elderly folks who might remember.
Yeah, yes, exactly. There are some people that were alive at that time. Yes, for sure.
Okay, so
Great questions. All right,
head into the road and we'll carry on.
Head back this way. Continue down the road.
classified silvicultural systems, treatments that we use. So the one that we're going to look at right now is a way of managing for an uneven age stand.
Last 2 pages is, oh, actually, we're not quite there.
No, it's okay.
Page
So
3.
you just, so you know, you have the explanation of the concept of that on page 3, what it is. And in short, there are 2 very common ways in this region of managing for a stand that has multiple ages of trees in it. And the one that we're going to look at right now is something that's called an irregular shelter wood. And this one has expanding gaps. And this is a way of controlling stands that involves putting a certain amount of area in regeneration. So let's look at their harvest plan, which is the last 2 pages. This was actually the plan that they developed. This is a part of it. The whole thing isn't here. This is a part of what they used to actually do this treatment. So, as they wrote here that this is going to be an expanding gap. It's actually an expanding gap irregular shelter wood. And a pre-salvage. Pre-salvage just means there were some trees they thought were going to die, and they wanted to cut them before they died. And so here they were trying to balance multiple objectives. They wanted to sell some trees because they used the money that they earned from the forest to support the operations of the University Forest Office. They also have recreation here.
Oh, we might need to pause.
I think we should.
This was a great idea until the big truck came through.
I like setting up what they're going to look at before they
Pleasant smell of diesel.
There's also a lot of recreational use here, and that's one of the reasons why they wanted to manage for a multi-age stand. In even age management, we tend to reduce the density across the stand and let new trees start to grow and then take off all the big trees. So that can be quite a shock to someone who's just using the area to walk their dog or whatever. So forest aesthetics were important to them. And so this particular treatment, which is described on the bottom, but we can just look at the picture on the back. This is a map of the stand, and the yellow areas are...
They have black and white.
Oh, gosh darn it. Well, look at mine. See those yellow areas?
They're white on your map.
Okay, thank you.
The white lines. The white polygons.
This is where they decided to create gaps. And the reason they did this is they found... They went throughout the stand and they found areas where there was a bunch of trees that were starting to die and it was time to harvest them, or there was already some regeneration growing. And so they planned their gaps around those areas to capture mortality and to release new seedlings that were already there. And in fact, there had been some small patches cut in here for a study previously, and that let some regeneration start to grow. That stand we were just in, the canopy was so dense there wasn't much regeneration underneath. It's still in what we call the stem exclusion phase of development. Here, they took advantage of some natural or previously created openings and they enlarged them. And in doing that, they're trying to put more of the stand into a younger age class. And inside each of these gaps, they left a few trees standing. Some of them weren't ready to be harvested yet. They were immature from a commodity perspective. And others are going to be permanent. They're going to be for wildlife habitat. So what we're going to do in a minute is we're going to walk in here and we're going to look at a couple of these gaps. And we're going to see what decisions did they make on how big to make the gaps, which trees did they leave and why, and does it look like it's turning out to have a good outcome or not. So here we saw a lot of pine. I mentioned pine here. That's a very valuable species. So the University Forest has prioritized management for pine. So what they're trying to regenerate in these gaps would be white pine. And as I mentioned earlier, and you probably know, that is a species of intermediate shade tolerance. So it doesn't do really well under the canopy. It needs a little opening to get started. So that was the plan. Promise.
So prior to this harvest, there were some small gaps that were created as part of a soil compaction study that happened. I don't know when that was.
A decade ago.
Yeah,
or
a
more.
decade ago. So there's some small gaps that had some regeneration in it already. So these are now expanded gaps. So we went from what was an even-aged forest to a 2-age forest because we had these small gaps, and now we've got a 3-age forest. So we're moving from an even-age condition to an uneven-aged condition on this site. So it's in a way being kind of converted or transitioned into a different age structure than what was here originally.
Now the plan over time, because remember there's silvicultural treatments, that's what you do at one time. So this was an expanding gap, irregular shelterwood. The system is what you do over the long term. It's a plan. So here they had their little gaps, they made these bigger ones. They're going to come back in the future, and they're going to make them even bigger again until eventually the whole stand has been regenerated using this method. That's all I have on the road.
I think that's good. Yeah, I think let's go look at gaps, and I can.
Thank you very much.
Yeah, you're welcome. Yeah, I forgot that they all have black and white.
This is the better way to
Yeah, this is better than anything.
This one right here, the hardwood, was designated as a wildlife tree, so that will stay forever. Some of the pine, probably that one over there, they will come back in the future and harvest because they have a lot of value. So they're going to decide when they come back whether some of these they want to take or leave, but some are clearly wildlife trees. So there's two reasons, the way we describe that is there's two reasons for leaving retention. One is residual growing stock for trees that aren't ready to be harvested yet, and the other is a permanent retention for wildlife or biodiversity. And so that's what they've done here.
Or aesthetics or other reasons.
Yes,
Right.
absolutely. So one thing you will notice is in this small gap over here that was here already, that was only about half a tree height, maybe even close to 1 tree height wide. Most of the regeneration in here looks like fir. There might be some spruce in there, very little pine. That was still shaded because the gap was so small. Because they wanted eastern white pine, they made this gap much bigger. The other thing that you'll notice from an operational standpoint is we are standing on a logging trail right now. This was done as a cut to length operation, so that's a processor and a forwarder. A processor is a wheeled or tracked machine that has an arm that reaches out, grabs a hold of the tree, cuts it off, lays it down, and then it runs up and down the bowl and it takes the limbs off and it bucks it up into the size pieces that they want. The forwarder carries the wood out. So again, it has wheels or tracks, and it has like a big bed on it, kind of like a tractor trailer truck with no top on it. And it comes in and it picks up all the logs and it piles them on the back and drives out. When they do that type of operation, they lay the slash in the trails to help protect the ground, and they're not dragging any wood. So because of that, there wasn't a lot of disturbance out in the gap, and it was mostly concentrated on the trails. So laying out the trails in a thoughtful way can be important because remember I said they're going to come back and they're going to expand these gaps in the future. So this one, maybe they'll expand it more that way or that way, and they want to have their trails in a way that they continue to access their gaps without driving through their new regeneration. Now sometimes you will find that the trails are particularly good places for regeneration. It doesn't usually work if there's too much dead wood, but if you come in and you find that the ground was disturbed and it created a good seed bed, you might have a lot of regeneration there, and then you'll move your trail somewhere else. So those are some of the operational considerations that we have when doing a treatment like this. Then the last point I'm going to make before Amber chimes in is those of you who are closer to the front of the line, what did we see running out of the gap when we came up? Above, yeah. So having a large opening that has some young trees and other types of vegetation growing in it next to a high closed forest canopy can provide a really good habitat opportunity for white-tailed deer because they have the shelter and then they have the browse. And so if you're trying to regenerate a species that is very susceptible to deer browsing, is perhaps a preferred browse species. You could have problems by creating a nice big opening like this when there's a lot of deer in the area. So do you want to talk more about that, Amber?
Actually, let's talk about it more maybe at the next step. One thing I did want to point out, Laura did mention that some of the white pines were kept for seed purposes, to seed into the gap, but also they were important for creating what we call some high shade, so that it was not full sunlight out here, but that there was a little bit of shade cast, because we're talking about a shade intermediate species, right? So that was another objective that the person who laid this out had in mind, was to create a little bit of shade. Not a lot of shade. In fact, he was saying, he was here with us Wednesday, he said, you know, he would have probably taken this hemlock out knowing what he knows now, because it's just casting too heavy a shade over this way. And you can almost see there's a shadow where there's no pine regeneration in there. So you need to be a little bit careful about how much shade you're casting, and so thinking about your regeneration and the amount of sunlight that's coming in. And I love that you pointed out that with small gaps, they might be fully shaded, and so if you're trying to regenerate a shade intolerant species, that could be a problem if your gap is too small, and depending on its orientation and size, it may not get enough sunlight to get the species that you want. So I thought that was a great point.
Another thing that they did here is, in addition to cutting these gaps, which are white on your handout, they did some thinning in what's called the matrix. The matrix is what we often refer to the area between the gaps in the forest. The reason why they did that is because if there were some short-lived species in those gaps, they might not live all the way until you get finished cutting your gaps here. They're only going to come back every, I don't know how often, 10 or 20 years, and expand the gaps. So by the time you get through your whole stand with your gaps, some of the trees that were in your matrix might have died. Now, from a wildlife habitat perspective, that would be totally fine. That's the natural process that one would expect, and it contributes importantly to habitat. However, if you're managing for commodities, you want to capture that mortality. And so when they do these gaps, they also reached in with the machine where they could reach, and they cut some of those trees that they thought were going to die before they came back. And so this treatment is the combination of the gaps and the thinning to create a multi-age stand. So it's a shelter wood, because the new trees are influenced by some shelter of the overstory. And it is what we call irregular, because over time the stand will have irregular heights in these different areas. So this is an irregular expanding gap shelter wood. That's the official name of it. I also want to just mention briefly the white pine. Shall we step in there and look at some of the white pine?
Yeah, before you go on. So in the prescription, they told the operators that they couldn't drive into the matrix at all. So they could only grab the trees that could reach from the skid trails for the most part. And what would be the downside if you kept harvesting a bunch of trees in your matrix? Is there a downside to that in the long run? Thinking about the next time you're coming in and harvesting? What if you're taking a lot of trees out of your matrix? What is that going to start to impact? Ideas?
I can think of two.
I can think of two. Probably the same two. Hopefully, we'll see. Any thoughts about the problem with taking too many trees out of the matrix? Well, that's a possibility, especially if you were really focusing on a specific species each time and removing it. So that is a possibility. Yeah. What else? Maddie?
Well, if the matrix is supposed to be the space in between the gaps, wouldn't that just eventually get rid of it, and then you just have one giant gap?
Yeah, so you're getting at some of the issues of opening it up too much and getting too much light in there and getting regeneration maybe before you want it in there. Is that one of your two that you're
Yes, I was thinking about the fact that if you thin that too heavily, it will regenerate too. And so then you'll have more of the stand regenerated than you wanted to. considering there would probably still be fairly high canopy cover, you'd end up with the shade tolerant regeneration, which would be the fir, the hemlock, and if you wanted pine, then that wouldn't be ideal. I could think of one other too that Charlie mentioned to us
Yeah,
on Wednesday.
anybody else, especially as you're getting towards the end, maybe your last final harvest, what might be a problem by the time you get to your last harvest? Bringing the stand to full rotation.
So could you send operators in here with $1 million of logging equipment to harvest just a few trees? Do you think they'd want to do that? So
Yeah.
if this was my other one, I think it's where you were going.
It's
Amber.
where I'm going, yes. You're picking up on it. So the problem is going to be a volume problem, right? You need to have enough volume, which is part of your next lab report. You're going to be calculating volume. If you don't have the board feet for them to come in and remove, you're not going to be able to sell it and hire somebody to do the work. So you don't want to be constantly stealing volume from your next entry, right? So you want to be careful of how much you're taking because you want your next, time you come in 10 to 20 years to be commercially viable, and that you're not going to have trouble finding somebody to come and do the work. So you want to be careful how much you're kind of borrowing or stealing from the next entry.
That's right.
Yeah.
Yeah, because it costs a lot of money. There's depreciation on those machines. They're also paying off those machines with payments. They're paying the salaries of the people running machines, the equipment that they're transporting them here. So there has to be enough wood in the stand so that they can make more money by harvesting it than it costs them to do the job.
Yeah. So, and when you're just doing gaps and you're not harvesting the whole stand, you need to have enough volume in those gaps to make it worth the trip.
Right.
Or another operation may be very close by in a different stand,
Yeah.
which is something we can talk about at our next site.
Yeah. Yeah.
Anyway.
Excellent point, Amber.
Yeah, super. All right, should we go on to the
Let's,
next? Do you want to walk
I
out
want to
into
go,
it a little
let's
bit?
go right up here where this white pine is. We're going to look at it and talk about it for just a minute before we move on. From in the future, you want it to have a nice straight form. So I see one right there. So as you look around at them, you'll see some, like this one right here, that has one main stem, right? But then you look at some others, there's a good example between these two teeny tiny little snags, that has a bunch of branches coming out the top. That happens here too. Does anybody know what causes that? Yep, that's the white pine weevil, kills the leader, lateral branches take over as the new leader. If it happens enough, it turns into those giant bushy looking things you see growing in people's yards. From a commodity perspective, this degrades the value of the tree. So you have fewer options to get a quality saw log out of it in the future. There's two things you can do about that. One is if you're growing your white pine under a partial shade, the leader is thinner and it's less likely to have the weevil get on it and kill it. The other is if you grow enough white pine and they're dense enough, even in the openings, two things will happen. One, they won't all get weevil, and so you'll still have some good ones in the future. The other is if there are enough of them and they're all dense, when the lateral branch, so here's one, takes over as the new leader, it kind of has to still go up. And so over time, they kind of straighten themselves out. The worst thing you can do for white pine in this area where we do have a problem with the white pine weevil would be to come in right now and space them all out, like on an 8 by 8 foot spacing, because every single one of them would turn into a big cabbage. So that's just an example of how we need to think not only about what species are suitable to grow here, what kind of age structure do we want to have, but What are the other factors affecting the trees that might inform the approach we use to management? Red maple. Amber, do you want to tell us about that?
So what do we got going on with this red maple stump sprout here? Why are there all these short little stems down here?
Vegetative regeneration.
What was that?
Vegetative regeneration.
It is vegetative regeneration, but why do we have some that are tall and some that are really short?
If you looked up close at them, Amber, what would you see?
I see that they're missing their ends. Why are their ends missing?
They got eaten.
Yeah, they got eaten. So this is deer browse. And as we were saying earlier, deer are a problem sometimes with regeneration. Now, maybe not so much for red maple because they are trying to regenerate pine, so maybe the deer's doing them a favor by eating the red maple in this case. But what you can see is that some of the sprouts are now above deer height. So these are more likely now to make it and reach the canopy. These down here are starting to die because they've been repeatedly browsed. And we passed a red maple bush in the trail there that was completely mowed down. I mean, the whole thing wasn't above this height. And there's others, like the one right next to it. You see there's a stump. You know, the red maple on that, they've been completely browsed. So if we were trying to regenerate red maple, this would be a problem.
Now, from a commodity production perspective, the foresters from the university forest weren't really sad that those got browsed a lot because they weren't trying to grow red maple stump sprouts. Red maple is in fact a very nice and can be a valuable tree, particularly when it's grown from a seed and it has one stem. The problem with these stump sprouts is because they're growing off a stump, over time that stump will decay, and the decay tends to affect the sprouts, and they also will develop poor form because they're coming off the sides of the stump and they aren't rooted close to the ground. So for the objectives that this particular forest manager had, they weren't trying to regenerate a lot of those, and so, as Amber said, having deer browsing there actually was helpful with regard to the pine. But there are times when what the deer are eating is what you want to regenerate. And in this region, the #1 species that has been a problem for is northern white cedar. That's a preferred winter browse. And you will see, actually there's a little one there. There are some cedar out here, not a lot. The university forest managers have not cut any of those because they know if they cut them with deer populations at the level they are now, they're not going to regenerate any. So they're hanging on to the ones they have, and hopefully in the future there'll be a chance to have some more regeneration.
Right.
Questions about the gap or what we've looked at? Yep.
Well, would they ever just take that red maple out?
Yes, absolutely. So it's not uncommon to do what are called pre-commercial treatments or tending treatments to the submerchantable classes. And there's two ways to do that. One is mechanically, brush saws, very common, often used for conifer species, like if you were taking out fir. For red maple, what would happen if we just cut that off right now? It would grow back. Only when it grew back, it'd have like twice as many stump sprouts as it does now. So you can use mechanical means to cut back a sprouting species like red maple, but it's temporary. It will come back again. Now sometimes that's enough to let your slower growing conifers get an advantage. If you really wanted to get rid of that, you would use herbicides.
Good question.
Yep. Other questions or comments? Okay, what we're going to do now, I think, is we're going to go look at another gap that turned out differently from this one and talk about what is going on over there. irrigated. But this one looks kind of different. So what do you see here?
What's different about this gap?
Do you think that their objective of regenerating pine worked out as well here?
No.
Right.
There are some hiding in here.
There are.
There's a lot more of something else. What do we have a lot more of in here? What was that?
A lot more little trees.
Yep, non-tree vegetation.
Non-trees.
Anybody know what this is? It's prickly.
It's rubus, raspberries. So great for berry picking, but not so good for pine regeneration.
So rubus is one of those species like pincherry that can have dormant seeds in the forest floor, and when it's disturbed through harvesting and given a lot of light, you can suddenly have a big flush of rubus, and that's what has happened here. So as Amber mentioned, there are some pine in here. There's some that are about as high as the rubus. They're just poking out, and then there's little ones underneath. But they didn't get nearly as much pine as they thought they would. What do they have here for retention trees versus where we just were? Are there as many?
Do you see as many pines?
No.
So we're maybe missing some seed sources here, right? Because you need pines to generate pine.
So there's a few things that might have happened here. The first is that they didn't keep pine trees in the gap. And so maybe there wasn't as much seed, and maybe there wasn't that favorable high shade that Amber mentioned that the pine trees have. There are some pine in the surrounding forest, but they aren't so much right in this spot. In addition, the soil has changed a little bit. It's been subtle, but as we move from there, we've come down. And over there, it's quite wet. You can tell that because there's some cedar back there. And having a different soil type or drainage can influence what grows on a site. The other factor is that that gap was on the edge of a gap that already had gotten started, and this one was a new one they put in. So this one didn't have any regeneration in it at the time when they started it. The most reliable way to get a species in your new stand is if it's already growing there and you just release it and give it more light. If you're creating a big opening, there's a lot more other things that can grow in there besides the species that you wanted. So when we spoke with them on Wednesday, we talked about the fact that these pine are probably going to poke through the rubus. So this isn't a complete failure. But there aren't as many of them, they're not going to be as dense, and they're not growing as quickly. So Amber, you had asked about herbicide treatment then. Did you want to share that?
As well. So we said that might be part of the issue as well, was the
You're
type of logging system that was used. And so
I was just going to add to that, if you do have the type of operation that is like that does not disturb the site, and you want to have a little bit of scarification to disturb the forest floor to help something like white pine grow, you can do deliberate scarification. It's called active scarification, and that is sometimes done by paying the loggers extra to drag things around on the ground or to use the felling head to scrape the ground. I've seen that in different places. The university forest folks have themselves come in at some of their sites they manage after the fact and like drag chains or things around to disturb.
I think they drag tree logs around.
They'll take logs and they cut some of the branches off of these stubs and they just drive around with them.
And sometimes you can use like the big anchor chains and drag those across as well.
Yep.
The benefit of being a coastal state, you
That's
probably
right.
probably can get anchor chain more easily than in the Midwest or Kansas. Although they probably don't do much scarification in Kansas.
So I asked you about the herbicides.
Oh yeah, so herbicides. So So if you're worried about this rubus as competition for your, especially for softwoods is where it tends to be the biggest problem, is another option would be to come in and spray it with an herbicide. The thing to be careful about though is your choice of herbicides. You know, you want to use an herbicide that's specific to what you want to get rid of, but sometimes your species you're trying to regenerate might be sensitive to that herbicide, which is the case here. So if you were to spray the rubus, you'd want to do it very soon while your white pines are small and they're actually protected by the rubus. So you'd get the herbicide on the rubus and it wouldn't get so much on your pine seedlings. But once you have all your pine seedlings poking out of the rubus, that's probably not, you probably missed your window of opportunity to use the herbicide. So timing is really important. And also there's a cost. So you need to evaluate, you know, whether you want to just take the risk of letting see what the pines do, whether they do eventually come through the rubus, and you know, maybe you get enough enough stocking to be happy with that. But it is a little bit more of a risk, and if you're very driven by commercial financial outcomes, it might be worth the investment to have somebody come in and do some spraying.
Whether or not herbicides would be an option will depend on where you are managing. Different municipalities or some provinces in Canada do not permit use of herbicides. Also different land ownership. So for example, over on the White Mountain National Forest, which is our closest national forest, they use herbicides to control invasive plants, but they do not use them to control tree regeneration because public acceptance of that isn't there. And so rather than try to do that and then be told they can't ever use herbicides because people were opposed to it, they're only using them for the invasives where there isn't another option. We should probably mention invasives now while we're here.
Yeah, we can.
We were in one of these gaps on Wednesday and Charlie from the University Forest found some invasives and was like pulling them out while we were talking. If there's a concern about invasive plants, it is very important to do an inventory, even if it's just a meander survey through your stand before you do your silvicultural treatment if you're harvesting. Because invasive plants respond positively to disturbance. And so you could have a small amount of invasives in a shaded environment before your harvest that will suddenly become a ton of invasives after the fact. So it is better to go in ahead of time. If there's very few, you can just pull them. Otherwise, focused application of herbicide treatments, like with a backpack sprayer, could be done to kill those before. Because it's much better to control them while they're concentrated than wait until it's a widespread problem.
Yeah, in that case it was buckthorn that he was pulling. It's in another gap. We're debating whether we want to keep going and looking at more gaps or not, but I think if we do one more we could, you know, we could talk about the aspen. That's the one thing we are missing. But maybe we could cut through the sorrel to get out, maybe?
I don't see why not.
The only downside of going to this next gap is there is a lot of slash. So where's Sam? Sam, be careful. I don't want you to re-injure your ankle. So take your time. All right.
Okay. I don't know the way.
It's this way.
Rubus, not so much retention, and some white pine underneath. This one has a lot of what? Does anybody know? What is the tree species that's regenerating in here? There might be some, but what I'm mostly seeing is aspen. It's probably hard to tell because the leaves have been falling off.
And quaking aspen at that.
Yes. So, Keith, now you know where we're at.
We just arrived at this point.
You want to introduce Keith?
Yeah, so this is Keith Canody. He's the University Forest Manager.
Hello, everybody.
And nice of you to join us.
Yes, I
and
apologize for not being here.
oh no,
earlier,
that's
but
okay. We between the two of us, I think
We're doing good.
We're remembering
I'm
most
sure
stuff,
you were.
so we're doing
I
all right.
attributed a lot of stuff to
we
you.
have some capable people.
I'd say the university forest managers told us.
He knows more of the forest history than the two of us do. So you're going to see a lot of Keith the next several weeks here. and his staff.
Yes.
So one of his staff members, Charlie Koch, was the one who designed this harvest. And hopefully you'll probably meet him next week, I imagine. So objective. Do you want to talk about the objective for this?
Yes. Why don't we let Keith tell us, what were you trying to accomplish with this gap?
This particular
Were you
gap.
wanting more pine, or were you going for something else?
So this gap had a lot. We put it here. It was a new gap. It wasn't one that was expanded. And I should say Charlie decided to put it here, mainly to capture the aspen mortality that was going to happen. Because aspen, as we know, is a shade-intolerant, short-lived species, relatively. About 60 to 80 years with quaking aspen, it really starts to break up. So if we didn't enter this part, most likely most of it would have died by the time we got back next time. Aspen is a merchantable species. It didn't used to be, but markets change all the time. So Charlie's thought was, well, let's try and get this aspen before it dies. We'll send it to the mill and capture its value.
What did you sell it as? What product?
It could have gone as one of three things. It probably went as hardwood pulp. It could have, there's four products that aspen commonly go for. Big tooth aspen, which this is not, sometimes has an aspen veneer market. People say veneer and they get all excited, but it's a relatively low value product. It's used for the internal cores of hardwood plywood, so not the stuff you see, the stuff that holds the nice stuff on top. So if you have nice aspen, you can sell it for that. Hardwood pulp, which is ground up and probably would go to woodland down on the Canadian border, on the eastern border there, and be made into tissue, which would be toilet paper and paper towels at a tissue mill. Or it would go as aspen groundwood, which is a different type of paper process, and that would have to go over to Rumford in western Maine. Or it could be chipped up and turned into oriented strand board, or OSB, up in Easton or New Limerick. So panel sheets. So it went for one of those things. Probably ended up as hardwood pulp, I would guess, and turned into paper towels.
I'd say that's probably where a lot of aspen goes to, generally, especially in the Midwest as well. A lot of it goes to.
But it actually now commands a premium over regular hardwood pulp, generally if you separate it out and goes for groundwood, which did not used to be the case. It used to be an unmerciful species. We'd kill gobs and gobs and gobs of it to release other things. We still do sometimes, but...
What's groundwood?
Groundwood is a different type of pulping process. The pulpwood here at Old Town is cooked in a chemical solution. That's why the mill stinks. Groundwood is loaded into a big magazine and pushed down against large stones that actually grind the fibers off. So that's why groundwood mill doesn't smell. Pulpwood isn't cooked, it's sticky ground.
So Keith mentioned that you didn't used to be able to sell the aspen pulp, and that we went around often in the past cutting it down or killing it. And in fact, at the experimental forest where I work, it's conifer dominated, so fir, spruce, hemlock, and there always was a proportion of hardwoods in there. But when you look at our old records from the 1950s and 1960s, we were going out into the woods and killing the hardwoods with herbicides, even the full-size trees, because there weren't markets for them at that time, and they were focused on production of commodity softwoods. Well, a few years ago, the prices really changed. And suddenly, there wasn't demand for softwood pulp, and there was a lot of demand for hardwood pulp. So the hardwood pulp was very expensive, and the softwood pulp, you couldn't even sell it at some times. And so we got into a situation on our forest, and we had done this for research purposes, so this is a good thing to learn. We had killed so many of the hardwoods and left ourselves so much conifers that when we wanted to sell our wood for a few years, Keith had a very hard time finding somebody to do that, finding a place to sell it. So we talk often about maintaining diversity for wildlife, for other reasons, but there are reasons to maintain diversity for commodity production as well, because you don't know what the markets are going to be in the future. And so it's really a bad plan to put all your eggs in one basket and then find out that what you thought was going to be valuable isn't valuable anymore. So that's, I think, an important lesson.
Yeah. Some of the big landowners, we've talked about allowable cuts.
Nope, we have not.
Okay, so an allowable cut is basically, the simplest term, it's what your forest is growing every year. And if you want to maintain the volume of trees you have out there, you cut what's growing every year and you don't go above that, in the very simplest terms. Some of the big landowners now are planning each year about 130% of their allowable cut, so that to have it planned and all set up and ready to go so they can play the markets. So they're only going to cut 100%. They're not going to cut the 130, but they've got some extra. So if the hardwood pulp market is good and the softwood pulp market has fallen apart, everything is planned and set up to go get hardwood this year instead of softwood. So they're over planning their harvests with the markets in mind. They're still going to cut the same amount as they would. They're not going to over harvest, but they're going to shift to one species group or the other based on what the markets are doing for that particular year.
So you mentioned the aspen. So Charlie's plan here was to capture the aspen before it died. Some of the other parts of the stand probably had fir that were breaking up. And in fact, if we look behind us, this little area we just walked through, we see some fir trees that have been dying. Fir is also a short-lived species. We tend to lump it together with spruce. We talk about the spruce fir forest. Spruce live a couple hundred years easily in managed forests and can go over 400. Fir on a really good site, on good soils in western Maine, can grow, somewhere in the hundreds, but on wet sites like this and in this part of the state, fir usually start to decay and die between 60 and 80 years. And so what that means is that if you have a forest with a lot of fir in it, you need to plan to be able to harvest that before it all dies on its own if you're concerned about commodity production. That's called the pathological longevity. That's how long a species can live until something kills it. And fir is very susceptible to decay.
When was this cut?
This was cut in 2016.
In November.
Yep.
So it's 4 years old.
So it's had 4 growing seasons. What do you think of the regeneration out here? Is it good? Would you expect it to be better? Does it look really awful? What do you think?
Well, you won't hurt our feelings.
I will point out that a lot of these are missing their ends the way that the red maple were missing their ends.
You can see there's a few that are a little bit taller than the others.
But mostly they're like around the same height and they're all clipped off on the end.
And aspen on a good site can grow 3 to 4 feet a year. So this is a 4-year-old site now. So if that were the case, all these trees should be like at least 12 foot tall, if not taller. What do you think? They're looking short, aren't they? Right? So we have a deer browse problem here. And knowing that, would that have changed your mind about trying to regenerate aspen in a small gap?
Well, considering what we had was aspen in a gap, unless we were going to plant it, which we generally don't do, it's sometimes you've got what you got.
So here, you're just hoping some of the aspen make it through. In places where the species that you're growing are very, very valuable, like there's some very high value hardwoods in Pennsylvania where they have big overpopulation of deer, they will fence whole stands to keep deer out of them. But that is extremely expensive. Not just to put the fence in, but for upkeep, because they're constantly falling down and trees fall on them and stuff. So fencing is not something that's common in our region because the value of the trees isn't sufficient to make it worth your while to pay for that. But there are some parts of the country and some types of species, you're looking at black cherry stands, that would be fenced in order to keep the deer out.
What might be another strategy? Is there another strategy that would help us have a better shot at more regeneration, or regeneration that's going to survive to be large trees? more light, or maybe a bigger cut area. So sometimes with aspen, sometimes it's about just overwhelming the deer, right? So if you cut a really big area, or at least a bigger area, you have a lot more aspen regeneration coming in at one time, and the deer just can't eat it all before some of it gets above deer height, right? The other thing that helps is leaving slash out on the site. So the deer don't like walking through a bunch of dead wood. So you can use slash to help protect your regeneration as well by leaving it out through the site. And which there's a little bit here, but not a lot. Not enough to keep the deer from getting in to this small area.
Yeah, that's something with a cut-to-length system. The slash gets all smashed down. It's not like a cable skidder where you could cut big tops and leave them.
Right.
In New York, they're actually making walls around their cuts out of slash. So slash walls, which is big, huge 20-foot pile of slash all the way around their cuts.
Yeah.
Like a fence, basically.
Like it is a fence, and it's actually more cost-effective than a deer fencing. And it gives it lasts long enough for the regeneration to get up above the deer.
I mean, you really just need it to last a couple years.
Yeah, so they're thinking in 4 or
need
5 years, everything will be up high enough, and it'll be good. So
So,
here we don't do that for one reason. Well, and again, our species aren't as valuable, so it's not worth the effort. But they can't sell everything over there, so there's a lot of unmerchantable stuff that we can actually sell that can go into the slash wall. And we'd be not only losing money to the logger to build the slash wall, but also the money of the pulpwood and the hemlock and things like that they make the wall out of.
Well, and I think Keith made an important point, is that when we talk about slash being a deterrent to browsing, we're talking about sort of the tops of trees that are intact, right? So there's a little bit of that over here where a tree fell down. So inside those branches, there's probably some trees growing that haven't been browsed as much by the deer because they've got these branches sort of around them. And in the lake states, I've seen hardwood tops as well be effective in that way. Slash like this that's on the ground really doesn't do very much. It has to be a physical kind of protection.
Three-dimensional.
Yes,
three-dimensional, not compacted down.
So
not
Pete,
driven over.
we looked at some red maple earlier, and Amber talked with the students about stump sprouting on red maple. Do you want to share with us how the aspen have sprouted here?
Yeah, so these aspen are sprouting from dormant buds on the roots. These are root suckers as opposed to stump sprouts. So there's a hormone in the tree that suppresses these dormant buds that exist on the roots. And when you cut the top of the tree off, that hormone is no longer available, and that triggers the sprouting response of the aspen. So that's why they sprout. So if you want to sprout aspen, you don't want to disturb the ground. You want to do as little ground disturbance as possible, which is counterintuitive to some things. Some trees sprout more when you run over them, like beech. In particular. So you don't disturb the ground. You cut them in the winter when the most reserves are down in the roots from the tree, and you want to cut younger, vigorous trees. These were big, old, senescent aspen, which don't sprout as well to begin with. So your perfect recipe, if you want to see a perfect recipe for sprouting aspen, go see the clear-cut strip studies over on the Penobscot Forest. Young, vigorous, 50-year-old trees, cut in the wintertime, no ground disturbance, 3 years, 15 to 20 foot tall aspen everywhere. So that's the prescription to regenerate aspen. So what we're talking about, and that's important, is the sylvics of the trees. So the individual characteristics of your individual species you're trying to manage for. That's the sylvics. When they seed, how they root sucker, their tolerance of light, how fast they grow, how long they stay down in a small phase, and then how fast they shoot up. Those are the sylvical characteristics. And in order to practice silviculture, you need to understand the sylvics of your individual species. And here where we manage a lot of species, that's a lot of knowledge to gain. Fortunately, there's a really good book called The Sylvics of North American Trees, where you can look this stuff up and read about it.
They have the link.
There you go. If you're working with a species that you're not familiar with, I've done a couple of harvests on weird species. We generally don't try and regenerate aspen, but we just did 11-acre clear cut where we wanted to. So I read up on aspen sylvics, so I'd understand it a little more before we did that to make sure. It would be really embarrassing if we couldn't regenerate aspen. But
That book
want to study up on those things.
That book was published by the U.S. Forest Service, and it's what's viewed as a corporate property, meaning that it's like the Forest Service was responsible for that, not one or two people. And we're actually redoing that book now, and hopefully in a few years there'll be a new one, and it will incorporate things that we found out since it was originally done, and also some information related to climate change. That was published in, what was it, 1990. They weren't thinking about it at that time. The other thing I want to mention before we move on to the next site is we talked about the retention of trees for wildlife and for snags. So there's living trees that have value for wildlife, and then there's trees that have died. One of the things that you need to think about when choosing retention trees is you wouldn't necessarily want to choose a whole bunch of really horrible half-dead trees and say, oh, those are going to be my snags. I don't have to leave any nice trees. I'll just leave the crappy ones. Because they might all die in a short period of time. So if you want to maintain wildlife habitat, you don't just want to have it distributed throughout your stand, you want to have it distributed over time. So you need to be thoughtful about the longevity of the species that you're leaving and about their health and vigor, so that you can have some trees already dead, some that will die in a little bit down the line, and some further down. Tree species also decay.
Time is a really important concept in forestry because you're learning about all these things you're going to manage for, right? And we can't manage for everything in the same place at the same time, right? We can't have everything happening right here, but I can have stuff happening over here now, and over here then, and over here later. Yeah. So thinking about time and how it relates to how you can move a treatment around the landscape over time is a really important concept.
Yeah, and this idea of deadwood management will be really important for your third lab report. So that's kind of the focus of that, where you went and you measured live and dead trees and, of course, woody debris. A couple points going back a little bit. So that's the Silvix of North American trees. That's linked in bright space under course resources, and that's a great resource that you might want to reference for some of your lab reports. So don't forget about that resource being, or that whole collection of resources being available to you. I think it's also on the Vogler Library course resource page as well for forestry. So that's linked there as well, I'm pretty sure. What regeneration method is this that we just talked about in lecture yesterday? In terms of, like, if we just did this on the whole stand, what would this regeneration method be called that we just talked about yesterday? You were all in class yesterday, right?
Did these regenerate from seeds? These little ones we're seeing right now?
Yeah, they regenerated
there,
vegetated.
I heard it.
What was it? Coppice. This would be a coppice method if this were all you were doing on the whole site. So just to think about that, usually you would do it on a bigger area than this, but this is a sample.
Yeah.
A sample of the coppice method there.
So unless there was anything else, remember, I think we could head over to the selection stand.
Yeah, we were thinking maybe cutting through the matrix, maybe that it might be less treacherous. I don't know, the route you came in was
I put them all around, but anywhere else we go, it'll be fine.
We're just going to go head for the road. Possibly for this one.
yeah. So back to the road, any which way you want to get in.
about the longevity of these, right? So fir, we said 80 years max probably out here. Spruce, at least 200, probably more. Part of it being or shade tolerant among the species is that it can respond to release at a very advanced age. So a shade intolerant species, or even white pine, which is mid-tolerant, if it has been growing in a shaded environment for a long time, it becomes very poor vigor and has a small crown, and if you open it up, it will not grow well. The red spruce is able to respond well to release and to grow even if it's been sitting in understory for like 100 years, as long as it has an adequate amount of foliage on it. And sometimes you'll see, this one isn't a great example, but when you look on the red spruce, it grows each year, right? And so in between the whorls, how much it grew in a year. And sometimes you'll see spruce or fir. There's a fir right there. That's called a candelabra fir underneath this big spruce, where it has all these years that it didn't grow very much. So the branches are really close together. And then if it's released, they'll start getting farther apart again. And that is a way to tell that that tree had been growing into shade, and then it grew large in a more open condition over time. So right here is a mature red spruce, which is undoubtedly the source of the seed that allowed these red spruce to regenerate here in the understory. The seeds of red spruce do not travel very far, and they only last on the ground for a year. So it's not like you can expect them to grow and like, oh, they're seed banks or something. That doesn't work. There's no seed bank in red spruce. Red spruce is a species that's historically remained, like if we go all the way back to the pre-contact days before European species, there was a lot more of it. Because it's so valuable, since the 1800s, it's been repeatedly harvested. So now when you look at inventory data for the whole state of Maine, where red spruce used to be one of our most abundant species, the top two species are now balsam fir and red maple. And that's because balsam fir grows faster, has bigger seeds, seeds more often. Amongst conifers, it's the winner competitively. And the red maple, we saw sprouts when it's harvested. So sometimes when you're managing, you want to look for these species that would have been historically more abundant and think about perpetuating them in the soil.
Very few people know more about it.
Thank you. Any other comments on that? Just wanted to point it out while we're here. These look very nice. What are you doing already? Your pine are catching up.
I just did a radar check and are like, we're the luckiest group ever because there's like rain tracking just to the northeast west of us and just east of us. We're like in this little zone right in between,
Okay.
between us and the coast.
Fingers crossed it stays that way.
Like this running through here.
Do we have a question in the back?
I just wondered, like, how many people are growing, like, white pine and red spruce, and why, like, everyone wouldn't just grow white pine if it's most valuable.
Do you want to answer that?
Good question.
Why are we growing white pine everywhere, Keith? Red spruce.
Fine everywhere. I think that's a complicated answer. Part of it has to do with economics of money now versus money later, and the time value of money. This stand, if we cut all these pine now and invested the money, chances are we might come out ahead with our investment. But if we the alternative is if we hang on to these pine longer term, we'll have a much more valuable stand going into the future. So really, it becomes an economic thing of realizing income now or realizing income in the future. Landowners that have a long-term planning horizon, like ourselves, like some of the larger companies, like some of the older family ownerships, 10 tend to vanish for the more value species. If your goal, like some landowners is buy the land, harvest it, turn it over, sell it again, if that's your business model, investing in long-term, making long-term investments in your forest doesn't play out as well economically. So that's part of the answer. If everybody had a 100-year planning horizon and was going to realize the value at the end, then things might be done differently.
So we mentioned the fir grows faster, the hardwood grow faster. So if you want to get your money out of the woods, say 20 or 30 years from now, those trees will be bigger faster. We talked about how slow the red spruce grows. To grow red spruce to a size that'll be very valuable, you're going to have to wait like 2 years till you have sawtooth trees. So from that perspective, as Keith was saying, if you're looking at making a return on your investment in forest land earlier, it makes more sense to put your efforts towards trees that you can harvest. If you harvest small spruce and sell them for pulpwood, it's the same as fir, right? You don't get a premium for being spruce. So that only makes sense if you're in it for the long term. Yep.
The other thing is not all forest products are made out of white pine.
Yep.
No.
Very true.
So there's, you need a variety of different trees because they have different properties that allow them to make different products, right? So
And different sites are suitable for different species. Some sites are more hardwood sites that are green, hardwoods that grow there are more competitive, and those can be quite valuable too. So there's a lot of factors.
We make a lot of money on our white pine, but we make a ton of money on hardwood fluff because we have a lot of it. So on an individual acre, the white pine acre is much more valuable. Sometimes because you have a lot of this stuff that is so good, the volume adds up. On an individual harvest, we make much more money on the low value stuff. But always been looking forward to trying to get these ones that are nice to come along and grow more. Good question. It's a very complicated answer.
Bingo.
If you look on your handout, mine isn't stapled, so it's got all out of order. Here we go. Page 6 shows the distribution of trees by basal area class for different species. And I'm going to let Keith tell you about this because he developed a prescription. But the 2 pages he's going to be referring to are page 6 and page 4. So here, there you go.
Okay, so on page 6 you can look at the graph. I think yours is black and white, so it's a little more difficult to read. But this is so you're on the x-axis here on the bottom. You have diameter. On the y-axis is basal area. What those are: diameter, breast height, and basal area. So if you look at the distribution of tree species, you get these 2 bumps. It's sort of what we call a bimodal distribution. It means we've got a lot of small trees, or a lot of basal area of small trees, I should say. Not so many medium-sized trees, a few, and then a lot of basal area in bigger trees, which may actually be a few trees because a bigger tree has more basal area, right, than a small tree. Right? The area of the stump is larger. And in a selection system, what we try to do is create a stand that has a diameter distribution shape that looks a little bit like a backwards J, which means that we would have a whole bunch of little trees, fewer medium-sized trees, and fewer still large trees. So it would look kind of like this.
Page 4.
Page 4.
Page 4, I bet there is one. Yes.
Page 4.
Page 4.
At the bottom.
So that's what we would shoot for in a true selection system. Now, in a true selection system, these trees on this curve would all be different ages as well. The small ones would be young, the big ones would be old. All right? In this case, what we have, I think, is more of what we call a stratified even age forest. So these trees are probably similar in age, even the small ones and the large ones, but they, because some grew faster than others, they sort of approximate this backwards J distribution. So it's probably not truly an uneven age forest, but because the trees grow at different rates, it looks similar to what a truly uneven age forest would look like. And if you look out there, you can kind of see this. You see the cedar and actually if you look on the ground first from our last harvest, you see some regeneration, so some small trees that actually are younger, like particularly the white pine in here. Then you look up, 20, 30 feet, you see cedar and fir in this lower area. Then you look up above that, there's kind of what we call a mid-story of maple, which are probably 50, 60 feet tall. And then we have the big pine, which are probably 80 to 90 feet tall. So we have these layers stratified in the forest. In a true selection, like you'd see over on Dr. Kennefick's forest, you would have all the species would be distributed throughout the size classes and throughout the age classes. So there'd be 10-foot spruce next to 50-foot spruce, next to 80-foot spruce, and little spruce seedlings on the ground. That's a true uneven age selection. And this one approximates it just because the trees have grown at different rates. Our goal is to eventually have a more uneven age condition out here. Particularly because this is such a highly visible area. There's a big ski trail back there we crossed. University Park, the student family housing is right here. There's a snowshoe trail here, a mountain bike here, trail here. So a lot of people are going through this area. In even age management, we've talked about shelter woods and things like that. In even age management, there's a point in time where you have this really nice, say that's pine, a really nice big beautiful pine stand with little pine underneath it, or a nice big beautiful spruce stand with little spruce underneath it. But there's a point in time that you're going to cut all those big trees to release the little trees in even age management. And that's a very dramatic treatment where a lot of people are going to see it. It's perfectly good management from a forestry standpoint. It makes a lot of sense. Very efficient to do. But it's a shock to the system when all of a sudden all these beautiful 100-year-old pine trees are gone and all we have is 8-foot tall pine trees left. People will call it a clear cut even though it isn't. A selection, we always have mature trees on the site. So what we're doing when we harvest is we're trying to balance out this structure and cut trees from the classes where we have too many to form that nice J-shaped curve. So if we have a bump in that J, we cut from that diameter. But we're also always in a selection harvest. We're picking out the worst trees from all the different diameter classes and cutting those and trying to favor the better trees. We also determine what we call a max diameter for each species. So a diameter at which once a tree gets that big, we've decided it's mature and we're going to harvest it under our system. So it may be a 27-inch pine. If the pine's bigger than 27, I'm going to cut it. But I'm always making sure I'm looking at the smaller ones and getting rid of the ones that aren't very nice, and what we call tending the stand throughout that process. So that from an aesthetic standpoint, we're always going to have trees out here of all different sizes. And it's just a process to come back every 10, 15, 20 years, whatever we decide is appropriate. And we'll cut a portion of the big trees, we'll cut a portion of the medium trees, we'll cut a portion of the small trees. But we'll always have trees of all those sizes left after the harvest. So if you're walking through this stand, you'll notice, okay, they cut some wood, it looks different. There's some broken wood on the ground and some sawdust, but there's still a forest here. As opposed to even age management, where I've had this beautiful stand I'm walking through with these great big pine trees, and now they're all gone and all that's left is 6-foot tall trees. Very dramatic and can be very shocking to people from an aesthetic standpoint. So this is one of the reasons we've decided to try and push this towards even age management. So next time when we come in here to harvest...
Can I interrupt you for a moment? I have a question for you. So why would Keith not want to grow his white pine larger than 27, 30-inch diameter for a commercial perspective? What would be the problem with growing your pines bigger than that? Perfect.
Yep.
The saw blade's only so big.
Yeah, there's actually it's the debarker.
There's the debarker. Oh, yep. The debarker. Okay.
The debarker is what takes the bark off, and they only make them up to 36 inches for the mills we go to. so it won't fit through.
So
The other issue is as trees get older, there's more chance that decay organisms are going to enter them at some point. So there is a point where your quality starts to go down, even though your tree gets bigger.
So I just wanted to mention from a historical perspective, it didn't used to be back in the day that you could only cut a tree up to 27 inches or whatever. What has happened is over time, mechanization has changed, so technology has adapted to the forest. So we're now adapted to cutting and handling smaller sized trees because those very big trees are not as common. And so when you do grow a very big tree, then it's not the normal tree that goes through the system, and so all of the technology might not be adopted to it in the mill.
Yep. We can still sell a very big tree if we have to. They've never turned one away. So we looked at an uneven age system there and an uneven age system here. What's the fundamental difference between the two systems? If you look at the stands.
What about the spatial arrangement of the new trees that you're growing? What's the difference between the two?
The last stand, they're all kind of lumped together.
Exactly, they're in clumps, they're in groups. So we're regenerating a little bit of that stand at a time in a confined area, right? And the rest, maybe we're regenerating some on its own as it sort of breaks up and falls apart, but we're purposely regenerating discrete areas. Here we're trying to get regeneration scattered throughout the stand. It won't be in every place, but there'll be a little bit here, a little bit there. So over time, if you think about how that forest is going to develop, the first one we looked at, if you looked across the canopy, it's going to be kind of this shape, right? You'll have 30-year-old trees next to 60-year-old trees, next to 10-year-old trees, and across the whole stand, it will be uneven age, but in any one spot, it'll be less diverse. Here, if you look at that distribution, that same distribution is taking place, but we've got a 1-year-old tree next to a 30-year-old tree, next to a 50-year-old tree, next to a 70-year-old tree, all within the same little area, as opposed to a group here, a group here, a group here. So it's a different spatial distribution.
So I want to just talk very briefly about some terminology, so this will link to what you have learned or will learn in class. So the two ways of managing an uneven age stand that we looked at, the first one is the regeneration was controlled by the amount of area you cut. So that's called area control. Over here, you're trying to create a reverse J distribution of tree sizes. When you look at that graph, that's called structural control. The other thing I want to clarify is that we're talking about today, we've talked about regeneration methods. That's the harvesting you do to regenerate a new age class. And we've talked about intermediate treatment, so that includes thinning and tending. That is done to redistribute growing space or improve the trees you already have on the site. So, over there in the irregular shelterwood, we had some areas that were regenerated and some areas where they did some tending or thinning. Remember, we talked about them reaching in. So regeneration methods and intermediate treatments happen at the same time in different parts of the stand. Over here, it's all happening mixed up together. So where they're taking out one tree to regenerate right next to a tree that they're taking for thinning or tending. So here, regeneration and intermediate treatments happen at the same time in the same area. In the even age stands, which Keith has been talking about, you do your regeneration cut, you let your new trees grow up, and then you later come in and you tend or thin them. So it happens at different times, never together at the same time. So those are some important distinctions about those.
Mm-hmm.
Anything to add, Amber?
No, that was great. Those were some good terminology
Yeah.
high points.
I'm
I'm not the only one that's obsessed with terminology.
No. It's a thing that silviculturists do, and we do it for two reasons. We do it so we can communicate to other people, and if they know the terminology, they know what we did. If we just said we cut gaps, that doesn't really tell about the long-term plan. That just says we cut gaps, right? So that ability to communicate is important in ways that people can understand.
And I'm not a silviculturist, but from an operational, I have to make these things happen. So same thing. If I tell the loggers we work with, they know what a shelter wood means. And if I say we are doing a shelter wood, that means a certain thing to them. A stand like this is very complicated. We're probably going to mark all the trees. If we're doing a thinning, they know what that means. So again, the communication and between our staff, so I do the prescriptions and then my staff implements them. So if I tell Charlie, I want you to go out and paint a shelter wood in this stand with a residual basal area of 80 square feet, favoring these species. He knows what a shelter wood means. And he's going to paint that very differently than a selection with a residual basal area of 80 square feet. They'd be very different stands. So I've got the same basal area at the end, but they're very different stands doing very different things. And the terminology that I use for that is important, because then he knows exactly what that means and can mark it.
You'll also find, if you work for a public land management agency, the U.S. Forest Service is an example on national forests. When they decide to do a treatment, they have to give it a name from a big book of acceptable treatments that have been approved for the national forest that you're working on. And so if you know you want to do a certain thing, you have to be able to link it to that silvicultural treatment in order for it to get approved. And on those jobs, they'll have the silviculturist interfacing with the wildlife biologist, with the soil scientist. They all are working together in order to make that happen. And so you have to know how it relates to the big book of things you can do.
And it's not just the Forest Service that has this big book. Most public agencies that manage forests have a similar book, especially state forest management agencies have their own book of acceptable treatments, and
large private landowners will as well. They'll have a menu of 15 or 20 different treatments that they will pull from, and that relates back to their management plan. So we're doing so many acres of shelter wood this year and so many acres of this and that, and they label and track those things as well. If you're managing a big land base, that's pretty important. Doesn't matter who you are.
Yep. So one of the important objectives of this course is communication, right? Because many of you will not be foresters, but some of you will work with foresters, and so one of the key things that we want you to be able to do is to communicate using common language, right? So if you're managing for wildlife or for watershed protection or something, and you want certain things to happen to the forest, and you can communicate those clearly to foresters that you're working with. So so that's kind of our intent with the course. So.
Good example. If you wanted if you wanted dense spruce fir regeneration across a wide area for hare habitat or something, would this be the treatment that you might choose in this stand?
Just look like good snowshoe hare habitat, wildlife folks. There's a bunch of you in here. I'm seeing lots of head shaking.
Yeah. So maybe. So what you'd be saying is, I think if we can use some shelter woods and regenerate some thickets and then overstory removals, which is an acceptable term in this part of the world, but apparently nowhere else, final removal, we can create that. The selections are really good for this, but those are, because at least in this part of the world, a lot of wildlife management comes down to manipulating the trees, and that is where the forestry part comes in. So being able to communicate that is going to be really important, and having a good grounding in this stuff will help you achieve those wildlife goals. Oop, I'm ringing. How rude.
And that brings to a conclusion of this site.
Yes.
I don't know that I have anything to add here.
No.
Oh, I do have something to add here. Did you have to think about anything prior to harvesting here that you were concerned about releasing that you didn't want to release?
Oh yeah, we have a bunch of invasive species here. So common or glossy buckthorn. So we did a treatment over there to release or to eradicate or reduce the amount of buckthorn, because we did not want to release that. We wanted to release tree species and not this nasty shrub that takes over the world.
And what treatment did you do here, Keith?
We did a combination. So we did an herbicide treatment, which was using just a hand pump backpack sprayer. What's called a waving wand treatment. You walk back and forth and shake the wand back and forth on the backpack sprayer.
What chemical did you use?
We used glyphosate.
That was glyphosate.
This was the name brand was Glystar. It's a generic brand of Roundup, basically. And then we did a follow-up cut stump treatment also with glyphosate for the ones that were too big to get that way. So we cut them off and sprayed the stump.
And why did you choose to do that first?
Because invasives really like disturbance, and timber harvest is a great big disturbance, so it thrives on that type of thing. So rather than come back afterwards, plus some of our desirable regeneration like pine is not very very sensitive to the chemicals we're using. Some of them we can. If we were trying to do spruce or fir, we could manage that so we could spray over the spruce and fir at certain times of year and kill the buckthorn, but not it. But pine would be difficult. So better to get that stuff gone and free up the growing space for this than try and release this stuff afterwards. That's part of integrated pest management.
Yes, that's why it's important to know the sylvics of the woody plants you don't want to understand the best way to get rid of them as well. So when you don't want them.
So I have one final comment before we move to we have one final and last stop, right, Amber?
Yep.
That is about interfacing with the public. So Keith mentioned that a shelter wood might be very shocking to people, and so they were thinking more of a treatment to maintain canopy cover, but even with that, harvesting operations can be very distressing to some folks. They feel upset about that. And one of the things that you can do to help ameliorate that is to use signage to inform people what you're doing. So for example, if Keith was doing a shelter wood, but he put up a sign that said, we want to regenerate very thick spruce and fir. The natural disturbance was sort of part of the plan for that gap shelter wood. We talked about how those small gaps can occur from trees naturally dying. In this forest type, what we call stand replacing disturbances, so something like a fire, that would kill most of the trees in the stand, very rarely happen. The closest we would get here would be hurricane, a really bad hurricane, and that still wouldn't kill all the trees. And if you have a lot of spruce and fir, you can have a lot of mortality from the spruce budworm. But most of our disturbances are individuals or small groups of trees. So that's a good plan to manage these species, but the natural disturbance will still happen. And in this gap, what I suspect is when they thinned it, when they opened up the canopy, some of these trees became more susceptible to blow down and breakage than they had been when the canopy was closed and they had other trees around them. So have you talked about that in class, Amber, about tree form?
A little bit.
Okay.
Yeah.
So if a tree is really tall and it has a really little crown on it, what's the length of the crown called? Remember?
What's that term? When you're comparing the amount of crown to the
whole
total
tree.
height of the tree.
Live crown.
Yeah,
Thank you.
live crown ratio. So a tree with a very small live crown ratio, and actually here's a pretty good example right here. This small saw timber pine that's closest to us has a very small live crown ratio. The form of a tree is influenced by how long its crown is. So a very long crowned tree will be more conical in shape, and it has a better height to diameter ratio. So that's a more stable tree. This is not a very stable tree. So that's a tree that could potentially go down in the future now that it's more open. It probably is protected to some degree by having other trees near it. So if you're retaining trees that have